Today, we're going to be looking at one of the most intriguing and interesting challenges in testing DDR5. So we're going to be looking at the DFE equalization that's brand new in DDR5, present in the receiver, and how we can actually use that to our advantage to open up an eye diagram and have a lot better signal integrity. So for some context, I have a signal source here that I'm using to simulate DDR5 4800 speed signals. I have a DQS and a DQ. And if we take a look at the scope here, you can see the purple trace, I have my DQ channel, and on the yellow, I have my DQS. So you can definitely see the purple has a lot of ISI, some reflections in there. It's not a great looking signal, it's not very clean, and it's not gonna be the best to work with as far as pre-equalization, right? This is kind of what we're looking at here. So the first thing I'll do is I'll go ahead and open up our SDLA software, which is short for Serial Data Link Analysis. And you kind of think this is our kind of all-in-one tool for anything involving equalization, embedding, de-embedding, clock recovery, and all that sort. But today we're going to be looking at a specific implementation on it for DDR5 that we've developed. So just for some quick context, I have my channel 3 here, which is that purple trace, as my data input into this system, and it's going to go all the way around. And these kind of radio button styles here, this is where I'm selecting to move my probing point to, my virtual probing point. We have a capability now where you can see I have these points selected after the receiver, which means this is going to be actually occurring now. I'm going to have data that is post-equalized after the DFE, which is a really powerful capability. If I go into that receiver block, this is where we're actually setting that up. So again, we have that very specific DDR5 module now for this software package, and I've set it up and configured it so after applying this stream of data, it's going to train these tap values. We'll see a small graph pop up just for a quick visual check to see if it all makes sense, and then we'll actually see a comparison of an eye diagram before and after the DFE equalization. So let's go ahead and start that process by clicking apply, and we'll start seeing the scope do an acquisition, and then we'll see that graph pop up like I mentioned. Here it is. You can see that makes a lot of sense to me. I've looked at these a few times, and that looks like a pretty good curve there. And this is a really interesting part here. You can see on the left, this is our pre-DFE eye diagram without any equalization applied. And this is going to be a very common occurrence with DDR5, especially as you approach higher speeds like 6400. And on the right now, we've cleaned up that eye a lot. So this is post-DFE equalization using those tap values that SDLA generated from this graph. And now that we've really opened up this eye that we can see on the right, we can really make some more impactful and more valid measurements for our DDR5 device.